Hey, Anuj, can you hear me?
Yep. Can hear you just fine.
Oh, okay. So, hey, Anuj, can you hear me? Hey, Anuj, can you hear me?
Can hear you just Can hear you just fine.
Oh, I was getting some feedback here. And let's see. This is, mm, can you go? If you click on the little three dots there, does that allow you to share your screen? No.
Let me see. Oh, I'm getting situated right now.
Oh, okay. I don't know if it's going to allow me to. When you log in as a guest at the bottom, is there little
Dots. Is that what you're?
No, actually, when you log in, there's nothing at the bottom of your screen, is there, that shows like start camera settings or share?
I can start my camera. I have settings right next to that too, but there's nothing to share my screen actually.
Okay. And I see we have 4 people who joined. So guys, please bear with us. I know we're live streaming here, but we're new to this thing here, and I thought I was going to be able to make Anuj a guest and have him share his screen, but apparently I have to make him like an owner. I think that's what's going to be. I'm not seeing any other way to share your screen unless you want to send me your slides and I'll flip them through for you.
Oh, I got a share screen icon just now. I don't know what you just did, but I just got it.
Okay.
Gotcha. All right, let me see if I can share what I want to share. Once you let me know what you can see whenever I share.
Okay. Actually, the best way to do this is when you do your share screen, there's all the way to the right, there's something that says Chrome tab, and just put whatever in the Chrome tab.
Can you see my screen right now, what I have?
I cannot see your screen. Oh yeah, I can see it. Okay, here we go.
You got it?
Okay, yep, it's up there. Okay, cool.
Can you see the slideshow and everything?
Yep.
Okay, awesome. If you want to go ahead and just kick us off or anything, once you can, and then I can jump in to what I was going to do.
Okay, cool. And so thanks for joining, Dave. I see you joined. The other thing is there's like 5 people on here right now, but I really can't see who's on there. But I guess Anuj sent you the link, so that's how you were able to get in. There's a guest link that allow me to add people visually, but we're limited to 10. But there's only 5 of us right now, so I guess I could post, or you could want to share that link out. Or the thing is, I don't know who's logging in, who's not. So it's different, right? So, but I will just leave it like it is for now, I guess. So yes, well, welcome. I'm sorry about these technical difficulties. We're getting started, guys. I appreciate you guys joining here. So I'm using this thing called StreamYard that you see there in the upper left-hand corner. And what this allows us to do is it allows me to live stream this presentation. So we're actually live streaming right now to Facebook and Twitter and YouTube. And of course, since we're going to YouTube, we're actually going to be able to record this session, and since we're recording, we can you can see it later if you miss anything or you want to share it with your colleagues later. So today we are having a session that's going to be presented by Anuj. So I appreciate you, Anuj. You want to do a quick intro and give a high level thought on what you're going to talk about, and it's all yours. Take it away.
Cool. Thanks, Vincent. So, how's it going, everybody? My name's Anuj Singh. I'm a solutions engineer at HashiCorp. So, I actually work at HashiCorp. I've been at HashiCorp for about a year and 3 months or so, something like that, getting around there. And yeah, I've been working with these products, most of like the core Hashi stack, which is like Nomad, Vault, Terraform, and a little bit of Packer through my professional career. Before HashiCorp, I was at IBM for a bit, and that's where I kind of started learning about these tools when I was in the infrastructure space or in the cloud space. A lot of these tools came in handy. And today, what I wanted to go through with y'all is kind of HashiCorp's vision of what we call zero trust security and where our products fit in this vision that we're portraying out.
Anuj, I'm going to interrupt you for a little bit. You wanna turn on your camera so people can see you?
Yeah, I was trying to do that. I had no idea.
There's not a start cam for you?
No.
Next to the settings, there's a mute, start cam, settings, and then share.
Yeah. Let me see if I can get that going. I'll stop sharing real quick.
I mean, because I can share mine, but I don't.
No, let me.
There you go. Yep, I see you. Yep.
Awesome. All right, cool. Let me go ahead and start sharing my screen again. Okay. Okay, are we back?
Okay, so I see you, but I don't see your presentation now. Okay. I'm gonna stop my cam and see if that helps you. Okay, there it is.
Yeah.
Okay. All right. So we're good now.
Okay. Cool.
Sorry about that, guys. It's just learning pains right here. But
I myself am not into streaming or anything like that either, so still learning on my end too, right? I think this is my first time ever using Streamlabs, so you're teaching me something new today, Winston. I appreciate that. Yeah. Cool. So yeah, guys, like I was saying, what I want to go through today is our product Vault, because if you know from about last Thursday, we the last meeting we had, it was very much centered around Terraform and why Terraform. And if you see it, the slide that I'm sharing right now, you've got secure infrastructure and then secure authorization, as well as our data is what we have to worry about. And then we get into like the networking layer. So there's a general progression that we see with our products, and that they're adopted with the Packer and Terraform model, where Packer is your image builder for AMIs or VMware ISOs. And then you take those images and you give them the Terraform for infrastructure as code. And you say, I would like to provision a bunch of servers that are using, some sort of main.tf file that have state files stored with them. And now I've got all these servers in these different cloud environments. Well, there's something great about that agility, but there's also a lot of problems that come with that agility too. And one of the biggest problems that we notice is whenever people start getting more agile and start building out their server infrastructure in the cloud and start building the cloud environments more, keys and managing of those keys and those passwords and usernames and just those authentication methods and getting into those servers become harder and harder to manage. And I'll give you an example of something I was doing earlier this week, where I was using a GitOps approach with Terraform, where I was having pull requests. Every time I create a pull request at GitHub, it would go and commit Terraform code based off of that pull request on that Terraform manifest that I had in GitHub. One of the things I had to do each time I did a CLI run was put in my GitHub API token and use that as a way to allow GitHub to talk to Terraform. And then say, Terraform, this is the change in that GitHub repo. I need you to go and do this and build this out. In the environment I was using was Azure for this instance. Well, I had to manually input that each time. And I had my GitHub API token, and I would just keep re-entering that in, but it was not done like an automated fashion, right? It was me manually doing it, and I actually put this in a document, which is, I don't recommend anybody to do because this was just a testing environment, but it would have been very nice to have my GitHub API token kind of just automatically plugged into my CI/CD workflow, so I didn't have to worry about managing it myself or managing its lifecycle by myself as well. And that's something that Vault does, and why I think it's super important. So when we're thinking about Vault and we're in that area, the two main tenets we want to focus on are identity, machine identity, and then also dynamic creation of secrets for said machine identity. So what Vault does is any machine that tries to authenticate to Vault, Vault will assign that machine an identity. And that identity is what Vault uses anytime that machine tries to talk to a Vault cluster and says, hey, I need these AWS creds. Well, Mr. Machine, I need to understand your identity, or a cluster, I need to understand that identity. It could be Kubernetes or a VM too. It doesn't have to be bare metal. And once it understands that identity, a token is given to that machine. That machine's able to go in and grab secrets. So those are the two core tenets: is how do we identify all of the machines in our system? And then how do we make sure that we're dynamically getting those machines the secrets and the access tokens that they need without stepping on each other's toes and having to do this manually? Well, you get into this when we're thinking about that secure authorization realm, right? And that secure data at rest is very important too with Vault. You don't want your secrets sitting in disparaging corners of your environment, whether that could be sitting in an Excel sheet, it could be sitting in GitLab secrets or GitHub secrets, or you could be using Kubernetes secrets, which I'll go on the record here. I love Kubernetes to death, but please don't use Kubernetes secrets in any production grade environment. I think they're base 64 encoded, which is great, but it's not encrypted, right? You want to have secure data that's encrypted and it's being injected into your CI/CD at the right and opportunistic time. So when we're thinking about secure data, that's what we're thinking is all of our passwords, all of our secrets. We want to put that in our Vault and then have our Vault kind of broker the authentication and the identity of machines that need that. And then we go up the stack a little bit more. I won't touch too much on console and boundary because that'll be in our next following session. Right now, we want to focus on Vault as we move forward from Terraform. So think of yourself as a sysadmin, and now you've just joined a company and they asked you to use Terraform, and that's great. You've built out a bunch of servers, but then after that, how are we securing those servers? Well, that's where Vault comes in. So giving an overview of what Vault is, I know this slide can be kind of intimidating when you first see it, but it's really not. We'll go through it. It really starts at the top when we're thinking about a client. Now, what is a client to Vault? That's the $1 million question, right? That's what is trying to authenticate to Vault to get a secret for a certain task. That's what a client is. So you'll see this maybe 90 to 95% of the time when I see people use Vault, these clients are machines. These are servers, these are VMs, these are clusters that are trying to get a secret and they're going and talking to Vault. The other 5 to 10% of the time is usually a human going in to get a password. And it's very important to make this delineation between Vault and PAM tools like CyberArk or any other PAM tool that you've seen. Thycotic is another big one, is that those are really to manage secrets and passwords of humans. And humans go into these password managers and say, I need a new password. I'm going to rotate this manually, and then I'm going to grab it. That flow can work with Vault, don't get me wrong, but the flow of what Vault is for is in this automation scenario that we created with Terraform, where we're building infrastructure so dynamically and fast that we need to automate the secret retrieval and the giving of these keys out to each environment. So that's where Vault kind of just pushes itself inside and says, this is what I need to do with Terraform, and this is how I'm going to do it moving forward. So if we start from the top here, let's say I'm a client. I am a Kubernetes cluster that's maybe sitting on-prem. And this on-prem Kubernetes cluster needs to scale out to my GCP environment or my AWS environment. Well, in order to do that and to start scaling in, you're going to need some credentials to get into your cloud environment. So in this case, I would need, like, let's say for AWS, a secret key and a secret access ID. And that can be stored inside Vault. That's good and dandy. But how does Vault know to give that Kubernetes cluster access to those secrets? And how does Vault know that that Kubernetes cluster isn't going to be repeating and using these secrets over and over again in different areas? This is where these guardrails start coming in with Vault themselves. So that machine, like I said, let's call it a Kubernetes cluster, comes into Vault, and the first thing it needs to do is authenticate. And authenticating is very much toggling to the Vault API, and the Vault API will go in and check its various auth methods that it has and see if that authentication method is even possible with Vault. So in this case, we have out of the box Kubernetes auth method that Vault has. So how Kubernetes and Vault talk to each other is the service account ID becomes that identity, that machine identity that is used by Vault to go in and grab a secret. So I'm that Kubernetes cluster. I'm going in, I'm authenticating. Vault says, hey, the Kubernetes auth method is up, it's running, that's good. Now we've got to check the policies around the Kubernetes auth method. Is this a outside of the geo Kubernetes cluster that shouldn't be accessing any secrets in the geo that this Vault cluster is running in? What is the size of this Kubernetes cluster? All these questions need to be answered before Vault is going to give back a secret in any way. So once these policies are checked and the authentication method is checked, what Vault is going to do is spit back out a token to Kubernetes and say, you're great Kubernetes, we like you, you can come in and grab a secret. And mind you, these policies that were written for that authentication method also limit the scope of the secret engines too. So that policy is going to go in and say, this Kubernetes cluster, because of the policies written by a Vault admin, it only has access to secrets that pertain to AWS and Google Cloud. In this case, we're getting AWS. So Vault is going to say, okay, great, you've got your token, and that token is only valid for 2 different secrets engines in this scenario. So then Kubernetes goes in and says, all right, give me my AWS creds. Vault says, yes, that's great, you absolutely can, you're valid. And then from there, that secret is sent back to the machine. And that's really like a workflow of how Vault goes in and can affect an environment. In this case, it would be a Kubernetes environment. So Winston, I'm going to stop here and ask if there are any questions in the chat or anything like that. I can't even see the chat, so I'm going to ask you to help me out here. Yeah. If Winston is still there. No? Okay, no worries. Let me actually go ahead and check the chat myself here, just to make sure we are okay. Oh, yeah, we're okay. Okay, good. Moving on to what next? Let's actually look at some workflows that Vault is involved in. So now we've kind of understood what is Vault, how does it work, how do we use it, but what are actually some use cases, right? And I didn't want to put in, boring architecture slides or sales slides here. These really focus on the actual workflow of how Vault interacts with these different secret stores. So in this case right now, we're going to work with the KV secrets engine. The KV secrets engine is key value, right? User passwords, API keys. It's very much just an input of, 2 inputs, X equals Y in terms of KV. So in this workflow, right, I've got 2 applications, right? My application A is sitting inside AWS, and then my application B is sitting on some on-premise store. This could be a data center. This could be, a server box just sitting in the office. It just depends on where this identity B is. So the main goal here is we want identity A to be able to talk to identity B by getting some sort of credential. So in this workflow, IAM ID to app A, that's what we're going to get in because we had to get into app A first. So we went into AWS and we got that IAM ID. And then app A is going to authenticate to Vault because app A wants to talk to app B. But in this case, app A first needs to get the credentials to talk to app B. In this case, these would be KV credentials. So Vault, after it tries to authenticate, like I said, Vault is going to go back and verify that this ID is correct within AWS. All right, is this the right auth method, AWS? Are you allowed to come and talk to me at Vault? And then once that identity is verified, Vault returns that token, like I said. And before we go any further here, it's important to note this token is wrapped with a bunch of policies. So not everything is being shown to this application A and insert in this policy set, because the policy that we wanted is, all right, AWS, you can come in and you can go and talk to application B, and Vault will give you those credentials for application B, But Vault first needs to understand what's authenticating and if we want to allow or deny. So in this case, we're denying all and we're allowing KB, B, and we're getting the password for app B, but we denied everything else. And if you see right here, it's very important to note, there's always a time to live associated with your credentials that Vault gives you. And that time to live can be, in this case, 60 minutes. It's customizable. Now, this is super important and super helpful when, let's say you're collaborating on a project together in AWS, or you're collaborating on a project together in some sort of like a GitHub or in some VCS control, and you've got to start giving out these API tokens and these credentials to a lot of people. Well, you can give those credentials out, but wouldn't it be nice if these credentials were dynamically created and that the fact that the time to live is scoped to however long you want this person in your environment or this company or this consulting firm in your environment? That's where time to live comes and can be very valuable, is that it stops long-lived secrets. We don't want long-lived secrets, long-lived credentials sitting out there anymore. And it forces that rotation of those secrets. So with that, when your friend comes in who's working on the same project with you, or a consultant comes in and says, hey, my Vault credentials ran out, well, they've got to re-authenticate again and grab new credentials, because what we're trying to do here is make sure that there's no point of failure in terms of where our secrets are being kept and who is using our secrets. So app A is going to go in, and after it's gotten that token, it's going to go and request a KV secret. And it's going to say, I want the KV sitting inside the path. Very important to know, Vault is very path-based, like a file system. I need, from KV, I need application B's secret, and that secret's a password and username. Because this is just KV, like I said, it's usually user pass. Well, great. Vault says, yes, you authenticated correctly. Yes, you have the right token. I check with AWS. Boom, I'm going to give you back that return value. And then app A is going to request to app B by doing some API curl command right here. So this is a very general use case for KV, but a lot of the times the skeletal structure is followed throughout the KV secrets engine use case. A lot of this is done the same. There could be some extra steps put in there, but this structure, this flow is very much how KV works. And you can get a nice visual right here of it all together. All right, so the next workflow I want to talk about a little bit is Dynamic DB. Another great use case by Vault. This is when we're thinking of database. So think of like your SQL credentials. Think of like DynamoDB getting credentials into a table like that. That's what we're looking at here when we're thinking about databases. So from this sense, we're going to go in and we're going to have a K8s environment this time. We're spicing it up a little bit. And then we're going to have an AWS instance that has user pass for application B. So first thing that needs to be done is K8s ID to app A. And that K8s ID in this case would be a service account that's associated with app A. The app is still going to try to authenticate to Vault. And Vault is going to verify that ID again and say, is K8s a valid authentication method? Am I allowed to do this? And then Vault is going to return that token once it says allow for this database B and schema A with the same 60-minute time to live. So this is that policy check right here. This right in the middle is whenever Vault's verifying that identity, and it's given this machine a new identity. It's given it something to not just identify itself, but identify itself with the entire cluster that is also authenticating with Vault. And that identity is tied to the token with the right policies. So we've set up a lot of guardrails. HashiCorp has set up a lot of guardrails in Vault to make sure that there's no single point of failure, as well as there's no way of you seeing secrets that you're not supposed to see. Because a lot of times you'll see with Vault is that it's used for many use cases and with many different teams or many different users. And all of these users have a different story and a different reason for why they're using Vault. And they don't need to overlap and see other people's secrets or see other people's authentication methods. They should just be using Vault for what they need to use it for. Everything else should be in their own realm. And that goes back, right? Zero trust. We don't trust anybody, even people in our own organization, because I've seen it where cases where secrets are leaked in their own organization because people just aren't aware of it and don't move forward. So then once we've got that token, we can go back with that Vault token and we can put a get command and say, I need this schema A. The database is going to go in and say, all right, let's get the username and password and let's give it a time to live. It's going to return that over. And then app A is going to request to app B, and we're going to post that login as well. So like I said, all very automated, all very machine-based, very, very slick in how this moves forward. Winston, you still there, man?
Yeah, I'm sorry. I'm still here. There are no questions in the chat.
Thank you.
So we're good, and you're doing good.
Yeah.
Like I said, these is basically the growing pains things. I was trying to figure out how to unmute myself and unmute my camera and stuff. So, and then I was looking at the other at Facebook and Twitter to make sure everything's still streaming okay for you. So everything seems to be working smooth as expected.
Cool. Awesome. This next one is PKI. So certificate rotation, when we think about that, it's always a pain in the butt, especially if you're using stuff like DigiCert or your own certificate rotation software that you built in-house. Encrypting and decrypting these certificates, rotating them and making sure that they're still valid. A lot of times you'll probably, I'm sure people have seen this in the industry where certificates will have a 20-year time to live and they're just sitting there and they've not been rotated, because the likeliness, of course, of that getting breached is very small, but there is a likeliness of that and you've got to account for that. So this is where our PKI engine comes in when we're thinking about rotating of these certificate authorities and dynamic creation of them. That's really how this works. So in this case, we're sticking with Kubernetes, and we're actually pulling in Nomad inside this use case. So Nomad is our orchestration engine that competes with Kubernetes, also works with Kubernetes too. The main difference here, guys, with Kubernetes and Nomad, just to touch on it a little bit, is Kubernetes is orchestrating Docker or Linux-based containers, right? That's kind of where it's scoped to do. Nomad is really scoped to go outside of that. And when we're thinking about like high performance computing, or we're thinking about edge computing, and there are VMs that are sitting on edge, and there are bare metal servers that are sitting on edge, because a lot of times when you're trying to get out to the edge, you need strong, servers because they're out there on their own. Nomad is very, very good at orchestrating these workloads and making sure that the scale up and down of these workloads is being met. So we're not focusing with Nomad just on Docker Linux base. We're focused on Windows containers. We're focusing on VMs, and we're focusing on bare metal instances as well. So same workflow as last time, right? The K8's ID is going to come into App A, and that identification is going to be able to authenticate that to Vault. Vault is going to identify this as a K8's cluster. Now we've gotten that machine identity correct. And from there, Vault goes back and says, is this identity correct? Go in and return a token. In this case, we're getting a certificate, mesh 42, and we're going in and we're allowing for PKI. So these are the commands that you would write into Vault and say, deny all else, but allow this for this certain Kubernetes instance. And this ties in, like I said, to that identity aspect. The machine identity associated with this Kubernetes cluster may be different than the service account and the machine identity with another Kubernetes cluster sitting in another realm. And it's important to have these guardrails that deny access to different Kubernetes clusters and allow access to certain PKI certs and certain secrets there, because if you just allow the authentication method for Kubernetes to be wide open, all your clusters, all your Kubernetes clusters with different associated service accounts and namespaces are going to get to come in, and they're all going to see the same secrets, where you're not going to get that granular level of security. And it's like the world is open to all of the Kubernetes instance. In this case, we said deny everything else. We're only allowing PKI to be sent over to Kubernetes. That app A is going to go in now and say, hey, I've got my Vault token here. I need to get this. Boom. It's going to go in and it's going to get that certificate right here. And then it's going to be able to request access to that ID. And so, like I said, the ID associated with B, PKI based. ID associated with A, K8's based. These identities are able to talk to each other and recognize that identity because of Vault kind of acting as that broker of secrets in this identity. So it gives you a nice view again here. All right, so this one is the last workflow I want to go through. It's our transform secrets engine, and that's for format preserving encryption. A lot of times what this one is used for actually is in conjunction with other secrets engines. So I'll give you an example. When I'm working in a database and I'm adding new content, new spots into that database table, adding values, well, whoever has access to that database is going to be able to see those values, right? Well, maybe they shouldn't be able to see those values. You'll see that with customers that have a lot of banking information, credit card information that is stored in S3 buckets, or not S3 buckets, excuse me, SQL tables. You want to make sure that those are encrypted. So using that dynamic database secrets engine along with transform secrets allows you to start posting in actual content to those tables, those SQL tables, but now it's all going to be encrypted. You're going to have serialized numbers, serialized IDs on each column and each row of your databases. And that's just a way to kind of encrypt in flight and encrypt at rest, right? We want an encryption in flight too, because once it leaves the Vault server and the Vault system, that encryption, that central location is gone, but we still want to make sure that that information is encrypted. And this is what Vault's Transform Secrets Engine can do. So again, we've got AD this time, and we've got user pass for these two different identities. So AD is going to go in and try to identify AppA. AppA is going to go to Vault and say, hey, my ID is AD. Is that okay? Verify the ID. Return that token that we're going to go transform Secrets Engine, and we're going to have the same time to live. And then AppA is going to request transform Secrets Engine and go in with that Vault token and have an input here. So that input and that output is taken out into that Vault AD, and that output will be encoded or encrypted, excuse me, as it moves forward, and it's going to send it over to this SSN layer. Same workflow, same thing. And I want you all to be aware of this. As you saw all of my workflows, the same type of authentication, that triangle I was showing you, is used in a lot of these Vault use cases. It's just pick your poison in terms of the authentication method and the secrets engine. And also, if your authentication method doesn't fit the bill of like Kubernetes or AD or Nomad or AWS, not like the traditional sense, and you're wondering, how can I actually have Vault talk to something if it doesn't know the authentication of the machine identity? Well, Vault has a authentication method called AppRoll. AppRoll is extremely useful in this sense, where if I've got a bare metal instance sitting in my own private data center and I have no idea how Vault is going to be able to talk to it, what I can do in Vault is create a role ID and a secret ID, very, very, very similar to a user password. And I take that role ID and secret ID and I attach it to that server that's sitting on its lonesome, that bare metal instance. And now Vault has identified that machine. And not only has Vault identified that machine is now in the Vault ecosystem of identity. So other machines, other instances that are trying to talk to Vault will be able to use Vault as that third-party broker of secrets to talk to this new machine now. And it's all because AppRoll is able to go and identify this machine, send it an identity and say, you're part of the family now, you're part of the Vault club. You have permissions associated with your authentication, but you're able to see other apps that are trying to talk to Vault, other secrets engines that are trying to talk to Vault based off of permissions, right? We don't give the keys to the entire castle or the whole kingdom. We just do it basically off of permission. All right. And since that is the content I wanted to share, and I wanted to ask in the chat now, because if we have any questions or if we have any concerns, any thoughts.
Yeah, there's still nothing in the chat. So if there is any questions or anything you guys want to ask, please feel free to do so. I guess the next thing is I'll probably need to figure out how to do a poll here in the future so we can get some more interaction with these guys as well. But,
right. It's interesting. I've never used StreamYard before. And so you're streaming this to Facebook, YouTube, Twitter, like everywhere?
Yeah, and YouTube. And it's being recorded there, so anybody can look at this and we can see how we've been growing and how we're doing and to educate our community on the different products and what they do. So this is really cool. I'm glad we were able to do this. And
absolutely.
And
so what we want to do next, right? And we've talked about this, is we want to showcase how Terraform is actually used with Vault together. That would be a good next step for us to have as a stream. And I'll give a preview of that right now since we've got some time. When we're thinking about Terraform and we're thinking about Vault, Terraform is really used to codify your deployment of Vault, whether that's HCP Vault, which is our SaaS offering, or it is Vault Enterprise or Vault Open Source, which is our on-premise offering. So when I'm thinking about using Vault and how I use Vault personally is I use Terraform to just codify everything and manage the scaling of Vault out. And we're going to get into that in the next session. But a lot of our products, you'll see as we move from Vault to Console to Nomad to Boundary they tie in very, very well with each other, and they're used in conjunction extremely well. And we see this stepping, like this increase from Terraform. All right, yeah, we got Terraform. Now we need Vault. All right, now we've got a bunch of servers with a bunch of identity. Now we need to orchestrate it. Okay, let's use Console and Nomad. After that, what about the humans that are trying to come in and get secrets? Well, let's use Boundary as a password manager for that. And this stack that we have translates very much well into the cloud, any cloud provider for that sense. That's our founders were good like that to allow us in any cloud. And replicate how you create infrastructure, how you create your dream cloud in any cloud provider of your choice. So we'll get into that in the next one in more detail. But in this case, I just wanted to cover at a high level for y'all what Vault is, why it's useful, why companies I see are using it every day, and why it's securing some of the biggest companies' secrets and applications across the world. So
it's great. It's great. So any other use cases that you wanted to talk about that you didn't document there, or
I would nothing on my mind now. Those are the main use cases.
The main ones there.
I wanted to touch the ones that I would say like a practitioner on their own would be doing, right? And that's a lot of that's KV, a lot of that's dynamic DB, some PKI rotation, and a lot of transform secrets engine too. A lot of people want to encrypt their data when it's moving out of Vault and when it's sitting somewhere else. So that transform secrets engine helps a lot with that.
Yeah, and I guess the other thing is if somebody wanted to pick up Vault, I mean, would they just go to?
Yeah, that's a good question. So the best place is obviously learn.hashicorp.com. If you guys haven't joined our Discord at all, please join our Discord. We do post at the learn hashtag where there's our learn.hashicorp.com. That's really where a lot of our tutorials, a lot of help for getting started with Vault. And that's how I got started, honestly, too, right? Was I just got on learn.hashicorp and was like, let me start taking around, let me break things. And it's important to note, too, when you do start off with Vault and when you actually are just trying to become like sane with it and understand the language, run it in development mode and then run it also maybe on your desktop locally. Or you can obviously do a dev cluster in the cloud, or you can use our HCP free instance. But when you're messing around and trying to learn at first, development mode is great. It's easy to log into. It's easy to just click around and understand. Don't ever use development mode in any production instance or in any dev test instance or in any QA instance. Development mode is a misnomer, and I always want them to change it because it really should be just sandbox mode. Because people think, oh, I can use this for my development clusters. No, you cannot. You're going to expose all of your secrets if you use that. It's really used for sandboxing and playing around with. But that's what I encourage everybody to do is download the Vault binary, figure out how to create something on your own, and then look at a learn guide that says set up AWS auth method or set up the Kubernetes auth method. And then just get yourself associated and starting like that. And you'll be a practitioner in no time, right? You're a practitioner, aren't you, Winces?
Oh, yeah. So, and I guess there's a certification for this as well?
Yes, there is. It's the Vault Associate certification, and then we also have intermediate and advanced ones. But if you're getting started, the Vault Associate one is the best way to go. And to give you some insight onto like the process for that, it's a lot of multiple choice questions, a lot of like writing out, like saying, what do you think a client is for Vault? If this certain instance were to try to authenticate, what policy could stop it from authenticating? Stuff like that is really what the certification exam is going to ask you about. And then they'll also give you like a development environment where you actually have to input small commands for Vault. So not a terribly hard exam, but you will need to practice. And I do believe on our HashiCorp website too, we have study guides for the associate programs. So if you go into learn.hashicorp in the Vault section, do a little bit of digging. I'm sure you'll find some study guides there if anybody wants to get certified.
Oh, sounds great. Sounds great. So I still don't see any questions in the chat. I did post also our Discord in the chat, so please join our Discord. And actually, after I stop the recording here, we're going to go over there and we'll have like a little, after party there. So so we get everybody on camera, and if you want to be on camera, and you could ask questions directly that aren't going to be recorded if for some reason you don't want to ask a question. But,
yeah, we won't incriminate you. Right?
So yeah, so I guess if we don't have any other questions, just remember that every month on the third Thursday of the month, we are trying to have a normal cadence so that we can do these things. And as Anuj had alluded to, we are going to do the next one would be with Vault and Terraform and show you how that works. And I believe after that meeting, we'll probably have our quarterly meeting, which is going to be an in-person meeting. And we're working on maybe trying to do something at a pub or somewhere.
Yeah, we like in person as well. We had a great one. We had a good one with VMware the other time. We watched a movie, and we want to do the same thing again, right? We want to go to a pub, we want to go to a bar crawl, something like that, where we can get out and see each other and just talk tech for a little bit and relax. Stress-free zone.
Yep, and also use the Discord to make recommendations of where you would like to go, what you would like to see, and what other deep dives you might want to do, or any lunch and learns or anything like that, or any certifications that you're working on, and we can gladly try to help you with that over in the Discord. I mean, the Discord is really a place for us to meet, to chat, and learn. So please join the Discord. And like I said, every third Thursday of the month, we'll be here. Same bat channel, right? Same time. Whatever that saying is, right? So,
yeah, exactly, right. If that's it, man, we can wrap it now, guys. If there's no question for Winston and I, just wanted to say appreciate anybody who jumped on and wanted to listen. This is recorded as well, so I'm assuming Winston still puts this on our YouTube channel.
Yes,
check it out. Check it out. If you didn't get a chance now, recommend it to your friends. We're trying to grow rapidly out here in the DFW area, so any retweeting, any hashtagging of us, that helps in any way. So thank y'all so much.
Yeah. So thanks everybody, and just cut and paste that Discord, and we'll meet you over there if you want to join the after party. Cool. Take care. Thank you.
Bye.